So now I'll briefly go over the data population script in Python that I used to populate the MySQL database. So I will be using MySQL connector Python to establish a connection to the local MySQL database on my system and IMDb-py module. So first of all, we needed to get a database size of 1 GB. So I got the top 50 title IDs of top 50 IMDb movies from the internet, but that was not enough. So for that, I have a list over here of all the actors, quite a big list, and I pass this into this method, get movies by actors, that takes all the actors' names, iterates through the list, and using the IMDb-py module, extracts their filmography and the IMDb title ID of their films. So using that, I iterate through the IMDb title IDs and add the movie. So if it's successful, it adds; if not, it doesn't. So now let's take a look at the add movie method. So in add movie method, I have the first try block that tries to request all the API calls to fetch the data, and if the response is false or if you have a request limit reach. So I have the API keys list over here, and if the request limit is reached for one of them, the control shifts to the next one, and if all of them are over, then the program breaks. So after that, we have, if it's not a movie, then it will skip it, and then it will extract all the relevant information that I need. After that, if all is good, then we come to the next try block, which deals with inserting the data into the database. So first we insert that particular movie into the database, and we get the movie ID of the movie that we just inserted by using cursor.last_row_id. Then we insert the genre. If it already exists, and then it doesn't exist, and that's why inserting node is used. And then we get the genre ID of the genre that we inserted, or the genre that is already there, but we need it because we need to establish the relation by inserting into the movie genre table. And we use the same logic for country, languages, actor's name as well, but over here it's a bit different because it's a part of an is a relationship. So first we ignore it, and first we try to insert it into person if it already exists or not, then get the person ID, and then try to insert it into the actors table if it already exists or not, then get the actor ID, and then to establish the relationship. So movie actor, the actor acted in a movie, we use the movie ID that we had got earlier, and the actor ID, and the character name of the person in that movie. Similar logic is followed for director and writer, and then we insert it into the movie alternate names, and if everything is good, then the method returns true. And now we will insert into our new 4J database. So for that, we need to first convert all of our data in MySQL tables to a CSV file, and for that I have the queries over here. So the main thing over here is that we store genre, languages, and alternate names as arrays in the movie node. So we while generating the CSV file for movies, we will we will include this in our query as well, so that all the genres, languages, and alternate names are also outputted in the CSV file, and we store the specify the path of the CSV file over here, and uh, other queries for all the other entities and relationship. And after that, we come to the cipher query to populate all the data. So first, we load the CSV file from the path specified over here, and with headers. So headers like IMDb ID, title, plot, etc. So we load it from the path specified here, and we traverse row by row and create a movie node out of it. So IMDb ID will be equal to the IMDb ID of the row, and so on. And for genre, language is an alternate name. Since we store it as an array, we will split it at the colon separator that we had specified before. And then we have unique constraint on IMDb ID to avoid duplication. Then we create an actor node in the same way we created a movie node. Then we establish a relationship. So over here we load all the data from movie actor.csv and traverse row by row. So each row of movie actor has IMDb ID and actor ID. So merge tries to match or find the node with the particular IMDb ID, and actor, and this second merge tries to find the node with the particular actor ID. And once both the nodes are found or matched, we then create a relationship. So actor acts in movie, and the direction of this relationship is from the actor to the movie node. Similarly for director, movie director, writer, movie writer, countries as well, but in country just the direction changes, so now it's from movie to the country. And we now have the data population script in Python, where we use the neo4j module from Python module to establish a connection to our local neo4j database. We have the run query method over here, where we pass in the query and it returns the result. So I will use file IO to read all the queries in data population, then run it and print the result and then close the driver.